A pair of binoculars essentially combines two handheld telescopes to provide a magnified and detailed view. Objective lenses at the distant end of the binoculars capture light from the object being observed, projecting an image into the device, which is then magnified by the ocular lenses through which you look. These objective lenses are curved, which makes the image appear upside down. To straighten it, glass prisms are used inside each half of the binoculars. The manufacturing process of these prisms is meticulous. They are mounted on steel plates, sanded and polished through several stages, with a protective varnish applied to prevent dust contamination. Sanding with diamond powder and a final polishing with fine abrasives ensure perfectly smooth surfaces. To make each prism, two pieces of glass are glued together at a precise angle, using a machine that ensures maximum precision and the application of UV light to solidify the adhesive. This process corrects the orientation of the image, which is first rotated 90 degrees by one piece of glass and then an additional 90 degrees by the second, completing the correction. The lenses, which undergo the same grinding and polishing steps as the prisms, are then cleaned in a 9-step computer-guided process. A technician glues two lenses together to limit chromatic distortion, essential to maintaining image quality. Perfect alignment is crucial. Minimal misalignment can significantly impair vision. In the next step, an anti-reflective coating is applied to the lenses by placing mineral pellets in a vacuum chamber, where microscopic particles are deposited on the lenses, improving light transmission. Assembly of the binoculars begins with placing the lenses in the frame, which can be made of plastic, aluminum, or carbon, followed by cleaning the lenses with compressed nitrogen and attaching them. Before the prisms are inserted, glue is applied and nitrogen blown again to remove dust. An optical machine then aligns the focal points of the prism and corresponding lens, fixing them with additional glue and UV light. The binoculars are then filled with nitrogen gas to prevent fogging of the lenses. Each pair of binoculars goes through rigorous testing, including exposure to vibration, water pressure, and extreme temperatures, to ensure that the device functions perfectly under all conditions, both mechanically and optically. The telescope, invented by a Dutch optician 4 centuries ago, revolutionized human understanding of the universe by proving that the Earth orbits the Sun. Modern telescopes, which are much more advanced than early models, use mirrors to reflect and concentrate light, beginning their production by machining metal parts to form a structure capable of blocking out unwanted light. Production of the telescope's main mirror begins with a disc of low-expansion glass, which is machined to a precise concave shape. After a series of checks for accuracy of shape and size, the glass is ready to receive a coating that transforms it into a reflective mirror. Final assembly includes inserting the mirror into the metal frame and adding a mounting mechanism for the eyepiece. After a process that takes about 6 weeks, the telescope is ready to be used in space exploration, helping to unlock the secrets of the universe. The space pen, another incredible invention, is designed to write in extreme conditions, including weightlessness, underwater in intense heat or cold, and even upside down. This is made possible by an ingenious design that maintains a constant flow of ink to the tip. The space pen's distinguishing feature is its nitrogen pressurized ink, which allows the pen to function independently of gravity. First launched into space with the Apollo 7 astronauts in 1966, the space pen has become an essential tool for astronauts. Aircraft components, such as screws and bolts, require highly precise manufacturing and the use of corrosion-resistant materials to ensure the safety and integrity of aircraft. These components, made of aircraft-grade stainless steel, must pass numerous quality tests. They undergo heat treatments that increase their strength and coating processes to improve their properties, such as corrosion resistance. Each stage of production, from forming the bolts to finishing them, is carefully monitored to ensure that the components meet stringent technical specifications. After production, aircraft components are tested in various ways to ensure their ability to withstand extreme forces. These tests include exposure to prolonged vibration, water pressures, and extreme temperatures to verify that each part maintains its structural integrity and functionality under all conditions. The manufacture of these critical components is essential to maintaining the highest safety standards in the aviation industry, ensuring that each aircraft is able to meet the challenges of flight. In conclusion, whether exploring the universe through a telescope, writing in extreme conditions with a space pen, or ensuring the safety of flights with high-quality aviation components, each process and product mentioned represents a masterpiece of engineering and innovation. These tools and components have not only expanded the boundaries of our knowledge and capabilities, but also continue to play a crucial role in exploration and safety, demonstrating the importance of continuous innovation and manufacturing excellence. Meticulousness and attention to detail are essential at every stage of the manufacturing and assembly process, from material selection to final quality testing. Every component, whether part of a pair of binoculars, a telescope, or a device used in space or the skies, must undergo rigorous testing to ensure that it meets the highest standards of quality and safety. In the context of assembling binoculars, for example, after the objectives and prisms have been carefully glued and aligned, the process of filling with nitrogen gas is crucial to prevent internal fogging, a factor that could compromise clarity of vision. This step, along with silicone sealing to ensure a tight seal, underscores the commitment to creating a durable and reliable product. When it comes to telescopes, the importance of a perfectly concave main mirror and a high-quality specular finish cannot be stressed enough. These elements are critical to obtaining clear and detailed images of the universe, enabling astronomers to make new discoveries and enthusiasts to enjoy celestial beauty. The precision workmanship of the mirror, along with the careful assembly of parts, reflects technological evolution and the human passion for space exploration. The space pen with its pressurized ink is an example of how innovation can overcome the challenges posed by the extreme environment of space. The ability to write in weightlessness, underwater, and in extreme temperatures demonstrates ingenuity in solving unique problems, helping to make possible long-duration space missions and exploration in hostile environments. Finally, aircraft components, with their precise manufacturing and rigorous testing, ensure the safety and reliability of aircraft. Corrosion resistance, the ability to withstand extreme temperatures, and tightness under high mechanical stress are indispensable qualities that these components must possess. The manufacture of screws, bolts, and other fasteners follows strict protocols, highlighting how aircraft safety depends on each and every component, no matter how small. Through the examination of these examples, we can appreciate the level of precision, innovation, and dedication needed in modern science and engineering. Every product, from those used to peer at the stars to those that maintain safety in the skies, is the result of centuries of accumulated knowledge and the relentless human desire to push the boundaries of the known. The journey from conception to production of these advanced instruments and components illustrates the importance of continuous innovation and the pursuit of excellence. Each step, from initial design to manufacturing, from assembly to final testing, requires multidisciplinary collaboration among scientists, engineers, technicians, and many other professionals. This synergy is critical to overcoming technical challenges and producing products that not only meet current needs but also pave the way for future breakthroughs and innovations. With this in mind, training and education play a crucial role, preparing the next generation to contribute to this cycle of innovation. Encouraging curiosity, continuous learning, and critical thinking is essential to developing the skills needed to design and build tomorrow's technology. Science outreach and access to quality education in fields such as physics, engineering, mathematics, and applied sciences are therefore priorities for sustaining technological and scientific progress. The success of these efforts is reflected not only in finished products such as high-definition binoculars, telescopes that unravel the mysteries of the universe, space pens that function under extreme conditions, or aeronautical components that ensure safe flights, but also in the human potential to solve complex problems and push beyond known limits. Space exploration, understanding the universe, and ensuring safety and reliability in air travel are just some of the areas where innovation continues to shape our world. In conclusion, the narrative of these production processes, from conception to implementation, highlights the profound impact that science and technology have on society and the environment. It shows how, through dedication, ingenuity, and collaboration, seemingly insurmountable obstacles can be overcome, paving the way for a future in which current limitations may no longer exist. The legacy of these innovative efforts is a testament to human resilience and ingenuity, which continues to inspire and guide the advancement of knowledge and technology for future generations. If this video has sparked your curiosity and you would like to continue exploring the wonders of science and technology with us, don't forget to subscribe to the channel. Leave a like if you like the content and comment below with your impressions or questions. Your participation helps us grow and bring you more and more interesting and inspiring content. Join our community of enthusiasts and let's start this adventure in knowledge together.